Most people think smartphone cameras are already solved. iPhone, Samsung, Pixel. They all look good enough. But what if I told you the biggest leap in mobile photography is not about megapixels, lenses, or AI editing? It's about how light is captured at the sensor level. And Sony may have just introduced a breakthrough that changes everything. Because this is not just another camera upgrade. This is a shift in how every future photo and video is created on a phone. And it all comes down to one hidden technology called LOFIC. Here's where it gets interesting. What LOFIC actually means in simple terms: LOFIC stands for Lateral Overflow Integration Capacitor. That sounds complex, but the idea is simple. Think of your camera sensor like a bucket catching rain. Light is the rain. In normal smartphone cameras, that bucket fills up fast. When it overflows, you lose detail. That's what causes blown-out skies, harsh highlights, and dark shadows. LOFIC changes that system completely. Instead of one bucket, it gives the sensor multiple storage layers for light. So when light is too bright, it doesn't just overflow and get lost. It gets redirected and stored in a smarter way. That means more detail in both shadows and highlights at the same time. And that leads directly into the first major concept you need to understand. Concept 1. Dynamic range expansion. At the hardware level, dynamic range is the gap between the darkest and brightest parts of an image. Right now, phones fake dynamic range using software. They take multiple shots and merge them together. But LOFIC reduces the need for that. Because the sensor itself can hold more light information in a single exposure. That means fewer artifacts, more natural images, and better motion capture. Concept 2. Why night photography improves dramatically. Low light photography is not just about brightness. It's about noise control and signal clarity. When sensors struggle, they amplify the signal. That creates grainy, messy images. LOFIC allows the sensor to capture more usable light data before amplification is needed. So instead of boosting bad data, you start with better data. That is a fundamental shift. And it directly improves night photos, street shots, and indoor video. But here's the part most people miss. Concept 3. The hidden advantage in video recording. Video is harder than photos because it requires consistency over time. Traditional sensors struggle with rapid light changes. For example, moving from indoors to outdoors in one shot. LOFIC helps stabilize exposure across frames. That means smoother transitions, less flicker, and more cinematic footage. This is where smartphone video starts to look closer to dedicated cameras. And we are just getting started. Concept 4. Why highlights stop blowing out. One of the biggest weaknesses in smartphone cameras is highlight clipping. Think of sunlight through windows, bright skies, reflective surfaces like cars or water. Normally, these areas turn into pure white with no detail. LOFIC allows excess light to be stored instead of discarded. So you retain texture in areas that would normally be completely lost. That alone changes landscape and portrait photography. Concept 5. The real reason this matters for future iPhones and Android phones. Here's a key insight most people miss. Smartphone companies are no longer competing on lenses. They are competing on sensor intelligence. Apple, Samsung, and Google all rely heavily on Sony sensors. So when Sony changes the sensor architecture, everyone downstream is affected. That means LOFIC is not just a Sony feature. It becomes a foundation for the entire smartphone industry. And this is where things start to scale fast. Concept 6. Computational photography becomes less necessary. Right now, phones rely heavily on computational photography. HDR stacking, night mode, blending, AI sharpening, multi-frame fusion, but all of that is compensating for sensor limitations. With LOFIC, the sensor captures richer data up front. That reduces how much software correction is needed, And when software does less correction, images start to look more natural. Less artificial sharpening. Less overprocessing. More real-world realism. Concept 7. The surprising impact on battery and processing power. Here's something most people don't talk about. Computational photography is expensive. It uses CPU, GPU, and neural processing units. If the sensor produces cleaner data from the start, the phone does less work. That can improve battery life, processing speed, heat management, so this isn't just a camera upgrade. It's a system-level efficiency improvement. Concept 8. Why motion photography gets a massive upgrade. Fast movement is where smartphone cameras usually fail. Sports, pets, kids, street photography, you either get blur or aggressive shutter processing. LOFIC improves how much light is captured in short time windows. That means sharper frames without sacrificing brightness. This is one of the most overlooked advantages of this technology. Concept 9. The industry ripple effect. Most people are not thinking about once a sensor breakthrough like this exists, it doesn't stay exclusive. Other manufacturers respond quickly. Samsung develops alternatives, Apple integrates similar architecture, Chinese OEMs optimize for cost versions. Within a few product cycles, it becomes standard. So what starts as a Sony innovation becomes a global camera baseline. And that leads to the final concept. Concept 10. What your future phone camera will actually feel like. Imagine this. You take a photo without thinking about lighting. Indoors, outdoors, night, bright sun. It just works. No switching modes. No thinking about HDR. No retaking shots. Video looks stable, clean, and cinematic by default. That is where this technology is heading. And if LOFIC delivers on its promise, this is not a small upgrade cycle. It is a generational shift in smartphone imaging. Closing. So when you hear about Sony's Lytia sensor, don't think of it as another camera spec update. Think of it as a change in how light itself is captured on your phone. Better dynamic range. Better low light performance. Better video quality. Less reliance on software fixes. And ultimately, a more natural way of capturing the world. And if this technology scales the way it's expected to, it's very likely this is what future iPhones and Android devices will be built on. Because in mobile photography, the real revolution is not happening in the lens. It's happening in the sensor.